So this is going on page 25 when we're done. So write that up there. So when we're done, I'll never remember that it's 25 and you'll know where it goes. We're going to look at critical points today, increasing and decreasing. You've probably heard these things. You may have talked about some of them briefly. Oh, yes. So the restroom when we're done with notes. Don't want to miss the notes. It's the exciting part here. The critical points, and even if you haven't heard them or had to write them before, it will make sense. Like it's good when things logically make sense. You know, it can only kind of be one thing. It's a good thing. All right, so we're going to look at critical points. We have two types of critical points, right? And they are where the graph changes direction or shape. Okay? So when a graph changes direction or shape, the first kind of critical point is extrema. They are extreme values. Extrema is just a different form of the word extreme. They are points on the graph where it changes direction. Okay? That's when you have a minimum or maximum. So I'm sure you've talked about those words before, maybe not in the exact way that we're going to talk about them. But if you see, when we're talking about our y values here, my graph is increasing. My y values are increasing. Sorry, just doing weird things. Increasing, and then it changes to decreasing. That's where your maximum happens. It's decreasing, it changes to increasing. That's when your minimum. So it's changing directions, going down then going up, or vice versa. The other type of critical point we have is a point of inflection. Even if you've never heard those words before, I know for a fact you have dealt with a point of inflection because you have done cubic functions that look like this, and this right here is a point of inflection, right? Your graph is increasing the whole time, but it has this little wiggle in here, so it just changes the shape. So it's where it changes its shape. And that's why this here is a point of inflection, because the graph is decreasing, still decreasing the whole time. It's going quickly, then it slows down, then it speeds back up is what's happening. That's where you get that little wiggle in there. Okay, we good so far? All right. So then when we talk about our extrema, we have relative and absolute. So we're talking maximums and minimums. So if you see these first two, so we have four little definitions we're going to talk about. The first two, so we have a point with the greatest value, and then the next one says the point with the greatest value. Okay, so greatest value both times means we're talking about maximums, but they're two different kinds. It's either the greatest value compared to points around it, or greatest value over the entire domain. Okay. So if I have just the greatest value compared to points around it, so if I'm just looking at this little neighborhood of points, right? In pre-cal, we look at our graphs most of the time like as the whole graph. We don't look at little chunks of it. When you get into calculus, you're looking at little restricted domains a lot, just a little piece of it. And so in that little piece, in this point's neighborhood, relative to the ones around it, it's a maximum. That's what makes it a relative maximum. When you look at the graph as a whole, the maximum value, remember anytime you're talking about the value of the function, it's always the y value. So the maximum value or the maximum y value of the entire function makes that the absolute maximum. We all good so far? All right, so then we have a point with the least value, and again, it's either compared to the points around it or over the entire domain. So same idea, but with minimums. This is the lowest y, or the minimum y value for the entire function. That makes it an absolute. This one's minimum just relative to the points in its little neighborhood. So this would be a relative minimum. And this would be an absolute. Even if you hadn't heard them split up like that before, does it make sense? The names make sense. It's easy to keep them straight, right? Here's something that makes it a little tricky sometimes. If we are just looking at a little piece of it, a restricted domain, if I'm only looking at this part of this graph right here, just this part, you don't necessarily know that it's the absolute maximum because you don't know what the rest of the graph looks like. Make sense? But you would know that this point would have to be a relative maximum because it is the maximum relative to the points right around it. Okay? So absolute maximums and absolute minimums actually fit both of these definitions. So this absolute maximum, it is the least value over the entire domain, but it also has the least value compared to the points around it, right? It fits into both. That means that absolutes are also relatives. And that's important for some of the kinds of questions that you're going to get. You can only have one absolute. That's why it's called the absolutes. Absolutely, the lowest one you get. But the relatives, if I asked you here, how many relative minimums does this function have? The answer is 2. Now, the best name for this, we know because we can see the whole thing, is that it's an absolute minimum. But it does have 2 relative minimums. Does that make sense? So again, should kind of make sense why it fits both, but I can see how that's a little confusing sometimes, so just make sure you understand that. We'll talk about that a little bit more when we get to these. Okay? Any questions at this point? Perfect. All right. So let's look at some examples. So we have the graph and we have the equation. So as far as parabolas are concerned in quadratics, you were able to find the absolute maximum and mins of those in algebra too, because we dealt a lot with parabolas. But if I give you this function, I didn't give you the equation, but even if I did, you would not be able to algebraically find these points because that takes calculus skills that you don't have yet. So all we're going to really do with these is be able to identify them, know that if they're relative or if they're absolute, and figure out where maximums and minimums are. But as far as actually calculating them, that stuff gets left for calculus. All right, so let's look at number 1. This point right here. Okay, so that ordered pair, because it says give the coordinates and classify the critical points for the graph. So that's it. 1, 2, 3, 4. 1, 2, 3, 4, 5. So I think that's it. 4, -5. Okay. I would say it's pretty clearly a minimum. What would be the best name for that? Absolute minimum. And we can abbreviate. I didn't want you to abbreviate up there, but we can abbreviate here. So absolute minimum is totally fine. If I gave you this picture and I asked you, how many relative minimums does this function have? What's your answer? 1, because it does have 1 relative. The best name is absolute, but it has 1 relative minimum. Okay, we good with that? Okay, awesome. So when we look at this one, I know there's a bunch of points plotted, but how many critical points are there? 3, good. So I have 1 here, 1 here, and 1 here. The other 3 that you have, they are just intercepts, which they're important, but they're not. Hey, Holly, wake up. You're missing all the exciting stuff. Okay, so this order pair here, we're at -3. 1, 2, 3, 4, 5. Okay. What would be the best name for that? Absolute max. Good. Okay. This one, this point here is at 1, 2, 3, 4, 5, -5. What would be the best name for that? Relative minimum. Is it the lowest y value for the entire function? It is not. That's why it's not absolute. It is relative. Do you think this function has an absolute minimum? It does not, because this is the y values are going to go all the way down to -infinity. -infinity isn't a value. It's a concept, and that can get confusing. But so I don't have an absolute minimum. And that's just like here, I don't have an absolute maximum because my y values go to infinity. Okay. All right, so then I have this point here. This is at 2, -3. What would be the best name for that? Relative maximum. Okay. And then if I asked you, how many relative minimums does that function have? 1. How many relative maximums does it have? 2. Okay. Has 2. This one is also relative, but the best name is absolute. Okay. We good? Questions do we have? Okay. Perfect. Move on. So I have this point here, this point here, and this is -3, 1, 2, 3, 4, 5, -3, -5. What's the best name for that? Relative minimum. Because this is an arrow and it keeps going, right? All right, so then this point here, we're at -1, 1, 2, 3, 4, 5. What's the best name for that? Relative maximum. Good. All right. One more. How many critical points does number 4 have? 3. How many extrema does it have? 2. Okay. Has 2 extreme values because it has a maximum and a minimum of some sort, right? But then this is also a critical point, yes? So I have this maximum, this minimum, and then this other critical point. But these 2 are considered extrema, and this one is something else, right? Let's do the extrema first. I've got -2, 1, 2, 3, 4, 5, 6. So this is -2, 6. And what's the best name for that? Relative maximum. Good. Then I'll do this one. This is at 2, 0. What's the best name for that? Relative minimum. Good. I think we got the hang of this. Then this point, which is at 0, 3, what do we call that? It's a point of inflection or an inflection point, yes. So we can abbreviate. So I can abbreviate point as PT of, and then inflection, we're going to do INFL. Add the L so you don't think it's a point of infection because it's not an infection. Okay, it's an inflection. There's an L in there. It's just the little wiggle. Okay. What questions we got? Anything? Okay. So let's look at increasing and decreasing. Again, I think the concept of things getting bigger and things getting smaller should totally make sense. But there are some things that people get mixed up on here for good reason. I understand why, so I'll make sure and clarify that when we get there. But this says moving from left to right. So when we are talking about what's happening on the graph, we are almost always moving from left to right. There's only one little thing we do where we talk about going from right to left. Otherwise, we're talking on the x-axis. We are always going from the left to the right, okay? So it says moving from left to right, a function may increase, decrease, or remain constant. So I'm positive that you've talked about that concept before when you've talked about these graphs, even in Algebra 1. When we're going from left to right, we can see that the function is, and what we're moving from left to right on the x-axis, but we're talking about what's happening with y. What I'm asking you about increasing, decreasing, remaining constant is what is happening with the y values. So moving from left to right, my y values are increasing, then they remain constant, then my y values decrease, right? But notice x is increasing the whole time because we're going from left to right. Make sense? Okay, so we're going to write intervals. We talk about what's happening with y. We write about x. So we're writing intervals of the domain, even though we're talking about y increasing and decreasing. The only time you write intervals of y is when you were actually asked for it, like range. And that's pretty much the only time. Any other time you're writing intervals, you're almost always writing intervals of the domain. Okay, so you might have, sometimes you have to remind yourself that because you want to write about the other thing. So I'm increasing, this function is increasing, my y's are getting bigger, starting way out here on the x-axis at -infinity, and all the way until I get to -1. The y value is 3, but I don't care, Okay, we're writing about x. Yes, my y value's increased to 3, but don't care about that. That it is increasing on the interval from negative infinity to 1 right here. Does that make sense? Then we have to decide, because we're writing interval notation, if we're including stuff or not. We never include our infinities. Okay? Whether or not you include the negative 1, depending on who you ask, you could get a different answer. You can ask people that are, been mathematicians for years, and they will argue with other mathematicians about what the right answer is. You can pull out different textbooks, and they will have different things. Okay? So I'm going to explain to you why I believe it should be one way, because it's kind of a matter of opinion. But we're going to do it my way, because my way is also the way that Mr. Ackerman believes it should be. And if you're taking, pre-cal right now and then you take calculus, we want to kind of remain consistent so things aren't confusing. Plus, I think if we're all on the same page, it'll make it easier for you to remember what to do. Okay, instead of it could be this, it could be that, because it's the only thing that we do, well, not the only thing, but the only interval thing where it's kind of a matter of opinion. The other ones, it has to be certain ways. So let's just learn that it should be this way, but I'm just telling you, somebody could argue it the other way. So my feeling about this is we're increasing, right? And then it starts to remain constant. Well, at negative 1, is it increasing or is it constant? Do you know? I don't know. So do we include it on the increasing? Do we include it on the constant? Do we include it on both or one or the other? So instead, we just don't include it at all. When you're talking about increasing and decreasing, it's just always open. Okay? The good thing is on the AP exam, whether it's open or closed here, if it's closed here, that's a bad thing. But if it's open or closed here, they'd take it either way. But I think it's going to be easier for y'all to kind of understand that if it's increasing or decreasing, we don't include them at all. Okay, that way it's consistent. I think consistency is important when you're first learning. All right, so then we're constant now it constantly remains 3, but I don't care about that. We go from negative 1 to 1, 2, 3, 4. So from negative 1 to 4, we remain constant, and then they're both open. And then it's decreasing from 4 to infinity, okay? Not negative infinity. I know it's pointing to negative infinity, but that is the y value. We are writing the x value, okay? Make sense? We good? Okay. So we're going to write a little reminder over here. We are looking for make sure I say this the way I want to say it. What happens to y as x increases. Okay, that's what we're looking for. What is happening to y as x increases? Regardless of what that is, we write intervals of the domain. Which is your x. Okay? So what is happening to y as x increases, and we write about x. And again, that's something you might have to remind yourself sometimes because you're going to want to do the opposite. Depending on what it is, sometimes it can get confusing. All right, so let's look at this then. All right, it says give the intervals on which each function increases or decreases. So my function starts off decreasing till it gets to here, right? So it starts decreasing where? Negative infinity. Okay, it's pointing to infinity, but that doesn't matter. We start at negative infinity because it's as x moves from left to right. And it decreases until we get to negative 2. The y value is irrelevant. You can point to it, but it doesn't matter. It's until it gets to negative 2. Then it's going to increase, but then it's going to start to decrease here again. Okay, so I'm going to have to union that with, I start over decreasing at 1, the x value of 1, and I continue to decrease till we get to, bless you, 3. Okay, Everybody okay with that? We're talking about y decreasing, but we are writing increasing intervals of the domain the entire time. Okay, we good on that? So then, increasing, I start here and increase to here. So where do I start increasing? -2, because I'm writing the x value. And I increase till I get to 1. Then I start over increasing here at 3 and go to infinity. Okay? What questions do you have? You understand how that works? Okay. It's not that it's crazy hard, because it's not, but if you're thinking about it backwards, you can get yourself mixed up. So, all right. So then we start out here, right? I have to start out here at -infinity, and what's happening to my function? It's doing what? Decreasing. So I'm decreasing from -infinity to, and then I have an asymptote here, so I think I'm going to draw it in because then it helps me count a little bit better. 1, 2, 3, 4, 5. -5. Do we agree with that? Okay. Then I have to start over on the other side of the asymptote, and my function is doing what? Decreasing. So then I start over on the other side of -5, so I have to union that with -5, and I decrease to infinity. So my y values are decreasing the entire time, even though this is going to go down to -infinity, then it jumps back up to positive infinity. It wasn't increasing, it's still just decreasing, it just changed. Okay? So that means this function here is not increasing at all. And notice the only thing that affected this was my vertical asymptote. My horizontal asymptote didn't have anything to do with it. Okay? What questions you got? No questions? Are you sure? Okay. Then let's look at number 7. I'm going to start out here at -infinity, and what's happening to my y values the whole time? Increasing, okay? So I start increasing at -infinity, and I'm going to increase all the way to infinity. I don't have any decreasing intervals. Any questions about that? Okay. All right, so now we're going to talk about positive and negative. I think you know the difference between positive and negative, but let's make sure that we understand how to write our intervals of that. So again, we're going from left to right, writing about x, and it's what is happening to y as x moves from left to right. Okay, and my negative y values are down here. My positive y values are up here. What happens at the axis? Is it positive or negative? What's the y value on the x-axis? 0. Is 0 positive or negative? Nope, it's neither one, right? So here, whether or not we include them totally matters, all right? So we'll start off with, all right, starting out here at -infinity until I get to here. Those y values are all negative, right? So I'm going from -infinity to 1, 2, 3, 4, -4. Right? And I do not include it because what is happening at -4? What's the y value? 0. So if I include it here, I'm totally wrong because it's not negative, it's 0. Okay? So that's another reason why it's kind of good to just leave the other ones open and it's kind of consistent. All right, so then I would start over here and go to here with these being negative. So it starts over at -1 and goes to infinity. It's pointing to -infinity, but I don't care about that because I am writing about x, right? And these should always go least to greatest. So then it's positive from here to here, from -4 to -1. But again, I'm not including them because if I include them, that includes 0 and it makes it wrong. So if you do increasing, decreasing, positive, and negative, then you're not including any of them, and it just remains consistent. It makes it a little bit easier. Okay, you only have to worry about it on domain and range right now. Any questions? All right, you do number 9. Somebody is very popular. Either that or they're trying to contact you about your extended warranty or something. Okay, once you're done, check yourself with me. Make sure we agree. Don't ever just copy mine down. Try and think about it on your own. If you can't, I mean, with this many of you in here, I can't walk around and check everybody's. It would take like the whole period. So you got to let me know if you got questions. And if you didn't get that, if you automatically are like, oh, duh, I get why, great. You fixed yourself, you figured it out. If you're not sure why we don't agree, ask me. I promise you, you're not the only one asking the question. Yesterday, I don't know, it was one class period. 2 people asked questions that they were, I think, a little afraid to ask. But both times I could see the looks on other people's faces where they were like, oh. And I could tell like that question helped them too. So luckily people were going to speak up. All right. So I have that it starts positive at negative infinity, but it's pointing to positive infinity. Why are those different? Because this is the x value, okay? We're writing about x, even though it starts at positive infinity. Don't care. We're going left to right. It should go least to greatest every time, okay? Are we good? Any questions? All right. Then go ahead and fold this. Get it taped in the page that you have. You have some time left, so earbuds stay out, phones stay put away, get your tablets out, and start on Delta Math, or continue on Delta